Today we're going to be solving by factoring, and our objective is that we will be able to solve quadratic equations by factoring. So to review, the standard form of a quadratic is ax squared plus bx plus c, and it always has to equal 0. This is very important, this part right here, for what we're doing today. And that's because of the zero product property, which says if a times b equals 0, then a equals 0 or b equals 0. Or both of them can equal 0. So let's look at some examples. We have x plus 13 times x plus 5 equals 0. So what that means is this, think of this as our a and this is our b. Either x plus 13 equals 0 or x plus 5 equals 0. Well, now that we have these two small equations, we can solve for x. So subtract 13, subtract 13. Either x equals negative 13, or if we subtract 5, x equals negative 5. So this one was nice and gave us the two things being multiplied together to start. In other cases, we're not, and we need to get those factors first. So we're going to use what we used last class for factoring. So we're going to multiply a and c. 3 times 2 equals 6. Factors of 6 are 1 and 6, or 2 and 3. Since we multiplied to a positive and we want to add to a negative, both terms will be negative. Which pair adds up to negative 5? That's negative 2 and negative 3. So negative 2x minus 3x. Bring down my 3x squared. Bring down the plus 2. And I'll bring down the 0 in a little while. Let's worry about our factoring first. So group the first two, group the second two. These two both have an x in common. This will be x times 3x minus 2. Since my first number is negative, I know I'm going to divide by a negative, and they don't have anything else in common, so I'll divide by a negative 1. So minus 1 times negative 3 divided by a negative 1 would be positive 3x, and positive 2 divided by negative 1 would be negative 2. So my factors are 3x minus 2 and x minus 1. Now I'm going to bring down my equals 0 to all my steps. It's just easier to do it afterwards so it doesn't get in the way. Now I have two things being multiplied that equal 0, so I'm going to split them up. 3x minus 2 equals 0, and x minus 1 equals 0. So to solve here, I'll add 2 to both sides. 3x equals 2, divide by 3, divide by 3, x equals 2/3. Here I just have to add 1, so x equals 1. So now I'm going to kind of combine everything we've done with factoring. So the first thing, looking back to what we said at the beginning, it has to equal 0 to start. This does not equal 0. So what I'm going to do to make it 0 is I'm going to subtract everything that's on this side. I'm going to subtract it from its like terms. So that'll cancel and that'll cancel. 3d cubed minus 2d cubed would be 1d cubed. Bring down the minus 3d squared. Negative 8d and negative 2d would be minus 10d equals 0. Now if you notice, all three terms have a d. So I'm going to factor out d. d times d squared minus 3d minus 10 equals 0. So that I can factor what's inside, I'm going to ignore the GCF that's out front and just focus on what's in the parentheses. So 1 times negative 10 is negative 10. Factors of 10 are 1 and 10, or 2 and 5. Multiplies to a negative, we need one number in each pair to be negative. Since this is negative, we know it's the bigger numbers. So which pair adds up to negative 3? That's this pair. So I'm going to split negative 3d into 2d minus 5d and bring down my other terms, d squared and minus 10. So now let's group. Group the first two, group the second two. So these both have a d in common. So d times d plus 2. Both of these have a negative 5 in common. Take out the negative 5 times d plus 2. So my factors are d plus 2 and d minus 5. But I also have to go back and then bring down my GCF of d and the equal 0. So now each of these three terms could equal 0. So d could equal 0, d plus 2 could equal 0, or d minus 5 could equal 0. Here if I add 5, I get d equals 5. Here I would subtract 2, d would equal negative 2, or d equals 0, that one's already solved. That's all for today. Fill in your summary and I'll see you in class.